Welcome to Small Aid. This is going to be a bit of a technical video. I've been asked to do that by one of my viewers, and we're going to look at how to open and service this bore micrometer. This is a Chinese bore micrometer, and if you have any doubt about that, well, there you go. And it's a pretty good one. I bought it several years ago. It was, I did the whole assembly video, and it was very, very gritty and unclean and so on, not very smooth. So, but I didn't film the taking it apart and the parts of it. So let's do it and see how it goes. Right, so let's discuss the different parts of this micrometer. And before we start, in case you're new to machining and whatnot, our bore micrometer measures the inner bore of basically a hole. So let's say I need to know the inner diameter of this bore. Well, I'll just move it back. Put it back in there. And click it. This is supposed to be 1/4 inch hole. We're 6.27 millimeters in diameter, which is pretty good. So I can take it out and measure another hole. So this has 5 millimeter minimal reading diameter, and what you need to do to calibrate it is make sure that the 0 is against the central line there. So let's look at the different parts. There are several parts you don't need to address. I'll tell you which is what and what it does. And there are several parts you may have to do that if you want to clean and service your micrometer. So let's start with the things you don't need to address. First things first, this is the screw that you don't need to address, and it makes sure that this head, this jaw, is in line with this jaw. So basically speaking, just hold it on a round shaft. As long as it's locked, the shaft will not move, and it's centered. Second thing you don't need to address is this thing. This is a locking screw. So let's say we take a measurement of a fairly large bore, relatively speaking, just lock it. And let's say I can't read it right now, so I can just make sure it's locked, pluck it out, take a measurement, write it down, unscrew it, and I'm ready for the next measurement. Also, this is loose fitting. There's no need to take it off. Another thing you don't need to do is this. You don't need to take this one off. There's a locking screw, and the locking screw here, what it does, if you notice, let me put that all in. There's a tiny, tiny ledge here. I can put the blade of the screwdriver and run it along. I can't move it up and down because there's a sort of milled section here. Inside there's a blade, and this just secures the blade to sit exactly in the groove. This means the jaw itself, while I'm rotating part of the jaw, it will not rotate along with the screw, because there's a screw here, obviously. I'm screwing it in as I move the jaw outward. So this aligns the jaw and makes sure it moves back and forth in a centered manner. Also, no need to handle this. If it's working well, you can play with it. If not, we'll discuss what you can do with it in a minute, but generally speaking, I don't think you'll need to do this. So, back to service. Grip your main body shaft here tight and unscrew. Counterclockwise in normal fashion, and there goes your clicker. Clicks only in one way, of course. Alright, so that's part A, done. Part B, hold the shaft, unscrew the cover. I would highly suggest you work in some sort of a tray. I'm working over here my bench has a not fixed, but my bench has a lip that is spring loaded and moves against it, so it won't lose any screws. But you don't want to lose these parts, so make sure you work in some sort of a tray before you continue. Now what I'm going to do, I've already field stripped it and cleaned it while I'm at it, so it's finger tight, strong. So there are 2 locking screws here. You need to take them apart, and there we go. And now our jaw will just come out. Put it there. Okay, now you can unscrew your system all the way out. Now it's a nice and quiet day. Super hot in here, and I didn't turn the fan on for you guys so you can hear it's not doing anything out of the ordinary. It's a nice and smooth thread. It was really full of grit and grime when I first got it, and we should be near the end. There we go. So it's been disassembled. I'm pretty sure you can disassemble this part as well. Not sure if it's practically possible. It could be just pressed into place. So I wouldn't do anything with that. Take it as a unit. And as for this, well, you got several options. First of all, you can unscrew and rescrew the locking ring here. And this is sort of an interesting puzzle. Let me show you why. I'm going to take this screw off. It's a tiny screw, don't lose it. So I'll be very careful with that, and I'll put it over there. Take this one off. There we go. So unless I want to really strip everything down to bare metal, and this is as far as you want to go. So you can adjust this locking ring. We have a conical head here, some grooves which allow it to contract a little bit more, a little bit less, and then there's internal grooving over here, which could always use a little bit more TLC. So while I'm at it, I'll just make sure there's no grime. Looks nice and clean. I'm looking at the light, which of course you can't see. Looks really nice, and as always, oil and metal are wonderful friends. Just oil it a little bit. Regular machining oil, nothing fancy. And I'll put it back on. And that's the wrong way around. There we go. Come on. There we go. So what does it do? Well, the grooves here are not really cut all the way through. As you can see, there's plenty of metal over here. There's not a free cut that goes all the way. Had it been a free cut, contracting this would considerably lock, or apply a significant amount of force and just lock this setup, which is standard machining practice if you have a thread and you want to lock it tight. This does, to a certain extent, and if you're a machinist, I'm a hobby machinist, not a real machinist, and if you differ, if you have a better opinion than mine, please do share. In my opinion, what it does is just slightly locks it, and you can seriously apply some torque here, and I don't want to. So I'm just locking it finger tight. That's pretty good. It's holding there nicely, and we'll just apply a little bit more oil over the surface. Want it nice and oiled, and we're going to put that back on. Now there's another issue here with this thing. Let me wipe my fingers. As you can see, when you're locking this setup, and this tiny little locking screw, fire it back for a second. This tiny lock is threading onto the aluminum shaft here, and it cannot be threaded on the full scale surfaces, let's call it this way. So if you thread it onto a surface like this one, it will bulge up. It will not get into the sleeve. Okay, because there's not much room there anymore. And which means you'll have a tight spot when you try to move it like so, cover the hole. So it has to be internal, it has to be below the surface, and there are only a few spots where you can actually do it. And one's over there. So this is one surface you can lock it onto, and this is the other. And the idea is that you could basically choose if you want it right hand or left hand. Practically, this has been ground very poorly. There's not enough surface area here. I don't know if you can see, but there's a ledge here, like this ledge right over here. So I really can't lock the screw over there. It's also very sort of cumbersome, not user effective. I would just turn it nice and round and just lock wherever you want to, but they just chose to grind it in some sort of odd manner. And you could see that it's probably by hand. It's not even, like there's a ledge here, there's a ledge there, sort of, this is deeper. Let's say it's not really precision made, and skip that. Okay, so we've cleaned our tool, we've oiled the surfaces. Okay, I'm just making sure there's enough oil all the way down, and we are happy. Nice and clean. Touching it. So just clean up a little bit more oil. There we go. Back to assembly. So now that we're happy, we need to assemble it. Okay, so doesn't matter where you position it. You want to take this shaft, make sure it's nicely oiled. Right, there's, as I said, there's a blade there. Not sure if you can see it. I'll try and take a shot of it right now and add it in the video. So there goes our blade in there. I hope you can see that through there. So I'll add a picture of that, but the point is that the blade can rotate, so we can manually, if need be, move it from side to side. Just unscrew the nut here and you can move it back up and down and whatnot. And you want to make sure it's running along the dead center. Otherwise you will not be able to fit this shaft in there. Like so. There we go. And B, if you over tighten it like that, it's going to be hard to move the shaft. So I'm just tightening it and giving it 1/4 turn, maybe even less than that, and then we got a nice centered moving shaft, properly aligned. Okay, and let's get a little bit tighter. Okay, so back to assembly. Put it back in. thread it. Remember, the black inner ring, back inner nut, has been hand screwed. I'm not applying any serious force, so this is moving nice and easy. Very happy with that. Okay, so let's get to 10. Right now the number makes no sense. Put this back on, making sure it's running nice and true. And there we go, you heard the click. And I'm applying a little bit of force downward. And now I want to return these two. There are two surfaces there that are nice and looking ground. Not really ground, maybe turned. Not sure about that, but I want them to face each other. So we have maximal friction here. Right. So do remember that if you lock these nuts super tight, okay, let's do that. I'm just finger tight closing it. I can no longer move this one. Of course I did, but if I continue doing it and I'm locking it, it's locking against this nut. So this nut shouldn't be locked on the shaft, meaning you want it a little bit loose. There we go, quarter turn loose. I'm going to hold it with the plier. Put the second nut on there. Okay. And now we're moving, and they're not going to get released. So that's sort of the most complex section here, making sure they're set in place. And now we can put things back in place. So first things first, this cover, you can put this cover back in. There we go. Alright, so we managed to do that. Last but not least, now to lock it in place, you need a screwdriver. Just a little bit of force, not much, and it's not coming back out. Okay, so we have a working micrometer, but it's not zeroed in because the shaft can rotate anywhere it wants to. Right, so I'm going to opt for this surface. Take this tiny little screw and try not to lose it, because if you lose it, you're going to have to find another tiny little screw, and they're not easy to come by. Locked. Okay, so technically it's working now. Okay, we have it locked all the way back up, all the way forward in, but it's not zeroed. So what do we do? Well, two things. One, I see a light sort of movement of the jaw. So it's this thing that is not fixed. Let's give it a tight lock. Now it's not moving. And release a bit, otherwise it will not move. There we go. And you can still move it back and forth. If you apply too much force using the screw here, you will not be able to rotate it. So this gets capped, and we're done with that. Part number 2. Get it closed. Put the 5mm bore, not closed, in. And there we go. Now we need to zero it in. Our zero is here. This is not. So I'm going to unscrew this thing, shift it to this position, and lock it And now, ground 0. And back to working condition. So I would test it with something that I know has a really good tolerance, really fine work tolerance, getting all the excess oil there. Not just the 5mm bore here, but all in all, that's the way. That's how to disassemble and reassemble this. So, hope this helps you guys. Have a great weekend, and I'll be seeing you. Thanks for watching. Have a sweet day.